As we discussed briefly in Module 2, most well interventions are remedial operations performed on producing wells as they get older. This is because they require periodic maintenance. Some reasons a well may require intervention include mechanical failure, flow restrictions caused by sand production, a decrease in production due to the buildup of solid hydrocarbons, changes in reservoir characteristics, and to access additional hydrocarbon pay zones. Broadly speaking, well interventions are remedial operations conducted on a live well with the Christmas tree still in place. The term workover is generally used when referring to remedial operations where the well is killed, the Christmas tree is removed, and a blowout preventer is installed. Well interventions may be rigless or rig-assisted. Workover operations are normally conducted using either a drilling or workover rig. As we have mentioned, well interventions are carried out with the Christmas tree and production string in place. There are items of equipment included in the production string that may be referred to during this module, so let's describe some of them here before we look in more detail at the reasons for well interventions and the methods of performing them. Production tubing is installed to allow hydrocarbons to flow from the reservoir to the surface or for injecting materials downhole. It runs from the tubing hanger at the top of the wellhead down to a point generally just above the top of the production zone. A tubing hanger is the component mounted on top of the wellhead which serves as the main support for the production tubing. The production packer isolates the annulus between the tubing and the inner casing and the foot of the well. This is to stop reservoir fluids from flowing up the full length of the casing. It is generally placed close to the foot of the tubing, just above the production zone. Downhole safety valve, or DHSV. There are a variety of downhole safety valves, but essentially it is a downhole device that isolates wellbore pressure and fluids in the event of an emergency or catastrophic failure of surface equipment. The control systems associated with safety valves are generally set in a fail-safe mode, such that any interruption or malfunction of the system will result in the safety valve closing to make the well safe. As part of the production string, downhole safety valves are fitted in almost all wells and are typically subject to rigorous local or regional legislative requirements. The wireline entry guide is installed at the lower end of the tubing. Its purpose is to guide wireline tools into the tubing and prevent them getting stuck. Paraffin wax and asphaltene, a tar-like substance, are two of the most common problems affecting well production. They both restrict production and, if not dealt with, can stop the well flowing completely. Both are part of the chemical makeup of various types of crude oil, therefore, depending on the region, they may be part of the production process. With fairly readily, either mechanically with scrapers run on wireline, or chemically by pumping and circulating fluid through the annulus. Coiled tubing may also be run inside the production tubing to deliver chemicals to the bottom of the well. Scale is caused by chemical precipitation from produced fluids. This is just like limescale in a kettle. Scale buildup will eventually stop production, as the deposits can coat perforations, casing, and production completions. Scale may be removed either mechanically or by dissolving it. Some wells will produce sand along with oil and gas, which can eventually block the production zone. Because sand is abrasive, it can damage downhole tubulars and associated equipment, and it can also damage the production pipework and equipment on surface. The sand can either be removed mechanically using wireline or circulated out of the well using coiled tubing.